In this problem, light's traveling from water into a piece of glass with an angle of incidence of 48 degrees. What is the angle of refraction? So if we could picture here the boundary between this water with an index of 1.33 and this glass with an index of 1.56. And so I make my little imaginary normal line, and that's just my origin here. And so this incoming light is incoming here with an angle of 48 degrees. It's going to travel into this glass, but it's got a higher index. So that means this angle is going to bend toward the normal line. If the speed is reduced, then the angle is also reduced, and we want to solve for that new angle. Well, we use Snell's law, that the first index times the sine of the first angle equals the second index times the sine of the second angle. And so we want to solve for angle number 2. That means I need to divide everything by the second index. And then I need to move this sine over to the other side and really do the inverse sine of all of this fraction to get angle 2 by itself. So we need to do the inverse sine of 1.33 times the sine of 48 degrees divided by 1.56. All right, and you can break that up in parts. I'm going to do this part here and then take the inverse sine of all that just to make it easier on the order of operation. All right, so I need to take the inverse sine now of that answer that I just had. And so, indeed, we do get a smaller angle. We get 39.3 degrees.